3, 2, 1.
Good day, students. My name is Mr. KS Mabotja, lecturer in the Department of Mathematics Education at UNISA. I'm responsible for technology and media in intermediate and senior phase mathematics, module code MAE204Q. In this presentation, we are going to focus on assignment number 2, feedback. My contact details are there as well. You can contact me on the email as well as the landline because we are back in the office. Also, you should not give a one-sentence answer when the question is worth 5 or more marks. It is important to investigate, do research, and apply your knowledge and understanding of the mathematics content instead of memorizing what is written on the tutorial letter. In other words, when you answer the assignment questions, do not copy directly from the tutorial letter 501. In addition, what you need to do is to show that you understand the question by answering based on your understanding of the question. The tutorial letter 501 is there to provide guidance, not to be reproduced as answers in assignments. Your mathematics content knowledge counts a lot in arguments or in providing answers. Citations should be supported by your own views. Citations are not to be provided as answers to questions asked. Try to answer the given question. Do not deviate from what has been asked. These general concerns, we picked them up when we mark your assignments, where in instances where students will just reproduce what is there in the guide, which is actually plagiarism. So you should guard against that. Looking at the assignment number 2, in terms of question 1, the focus on this question was actually on constructivist learning theories. As you might be aware that learning theories guide us in terms of how learning takes place, and also equip us on how to prepare our learning material, learning of mathematics in our class. So in this question, you were required to base your answers on constructivist perspective, that is to discuss how learning takes place under constructivist perspective. Some of the possible solutions that one can think of is to define what a constructivist perspective means. This theory focuses on a change in meaning constructed from experiences. In other words, learners come to classroom being informed by prior experiences, of which sometimes we refer to it as prior knowledge. So their experiences count a lot in terms of constructivist perspective. It also based on a premise that continuous process of experience and reflection is often done in a group setting where learners interact with each other. In addition, they solve realistic and meaningful problems and to reflect on experiences, provide group learning activities in this case. So as a teacher, you should be able to use constructivist learning activities or approach in terms of developing your learning activities where students will be working together in groups. And lastly, you model and guide the process of constructing knowledge in the context of mutual problem solving. That is where the role of the teacher comes into play. That is to say, you are not just going to let learners rely on their previous knowledge or prior experiences in their learning processes, but rather you model and guide the process of their learning. In this case, you are supposed to look at possible medias or possible technologies that you can use in the teaching and learning of mathematics through using technology, not forgetting that you're focusing on constructivist perspective. So in these instances, you can think of radio programs, television programs, computers with internet, as well as models. These play a crucial role in the teaching and learning of mathematics. They can facilitate collaboration and communication among others, among students and as also instructors. They also help in providing a variety of complex, realistic, and safe problem-solving environments. So in short, when you respond to this question, think of possible medias, think of possible technologies that you can use in your constructivist classroom. And these medias or technologies are not actually limited to radio, television program, computers with internet. You can use software such as GeoGebra in preparing your lesson in a constructivist learning environment, because it's such a powerful tool to facilitate collaboration and a erupt discussion among students. Still on question number 1, on 1.2, you discuss how technology, pedagogical and content knowledge applies in the teaching of. You're supposed to substantiate your argument with 5 valid. So looking at this question, it talks about TPEG, which is technological, pedagogical, and content knowledge. When you respond to this question, first and foremost, you need to define what TPEG means in the context of mathematics teaching. So this TPEG, it's actually pedagogical content knowledge, means the representation of specific strategies and approaches that teachers use to deliver mathematical content effectively to their learners or students. Once technology becomes infused in the PCK mix, the product becomes technological, pedagogical, and content knowledge. So in other words, when you look at TPEG, it consists of 2 portions. Firstly, we think of pedagogical content knowledge. This is the knowledge that you need as the teacher, the knowledge of the content, the knowledge of pedagogies, and also the knowledge of the students that you must have as a student teacher. So in this case, the moment we bring in the technologies, for instance, if you go back to the previous question, where you look at the role of the technology, the moment we bring in the role of the technology in the TPEG or in your classroom, we talk about the pedagogical content knowledge, but with emphasis on technology. So after defining these 2 components, you must now look at your role as the teacher. So your role could be, for instance, to consider technology as a conscious component of each lesson and regular strategy for enhancing student learning. Technology influences pedagogy and makes content delivery easier and more comprehensible. You are not actually restricted to these facts. You can go abroad as a self-directed learner, go in depth of this question and provide your own but relevant facts to this question. You are not limited to produce what is there in the guide, but display your understanding of this question by using your own words. But once again, let those arguments that you are bringing forth be relevant to the question in hand. And in terms of question 2, you were provided with base 10 blocks, 10 grams, solid figures, and geometry planes as classified mathematical visual manipulatives. You may recall that these manipulatives or visual manipulatives play an important role in the teaching and learning. So it is important to you as a student teacher able to know how to use these visual manipulatives and how they can be used in the teaching and learning of mathematics. For example, you were supposed to describe how you can use each of these visual manipulatives in your classroom. Starting with base 10 blocks, they help students learn addition, subtraction, number sense, place value, and counting. They also help students physically represent what they are learning so that they can develop a deeper understanding of the meaning of each concept. So in other words, base 10 blocks help students to enhance or develop their understanding of mathematical concepts. The second manipulatives that we are going to look at is tangrams there. This helps students to explore the relationship between various shapes. Thirdly, solid figures allow learners about various or help learners about various geometry solids and their properties. You can manipulate each and color each shape to explore the number of faces, edges, and vertices. And these concepts, such as faces, edges, and vertices, they play important role in the development of geometry understanding for these learners, especially at the foundation phase. So if you want to show your learners or you want them to learn about faces, edges, and vertices of geometry figures, solid figures can help you in doing those activities. And lastly, geometric planes, they help students to learn geometry concepts. Moving on to question 2.2, you have an interesting picture to show in your mathematics classroom. What resource will you need? This question, again, it's a practical question. You think of what possible resources can you use in showing your learners a certain picture. It could be a picture of a graph. It could be a picture of a mathematical concepts that you need your learners to grasp. So in these instances, you can use apparatus or resources such as a projector where you can project. And when you look at the projector or when you choose the projector, you must also indicate or explain the specific activity that the projector is playing in your classroom. For instance, you can think of how transparent it is in your classroom. And also the other apparatus or resource that you can use hand copies or hard copies. You can do print out and give learners the hard copies of the picture that you want them to see. On question number 3, how can you use the following calculators to determine mathematical, computational solutions, products, and processes in the content area, numbers, operations, and relationships? This question, I have noted the error there in terms of the second last question. It was not clear. We'll address that part when we get to that point. The first calculator that you look at, it's a graphic calculator. In this case, you give a brief understanding what graphic calculator is and what it can be used for. For example, the graphic calculator is very useful in schools as it can be used to draw a number of graphs on the same Cartesian plane. This allows learners to interpret, analyze, and compare the characteristics of functions with relative ease. For instance, you could program in the following linear equations. Now, when you bring in these linear equations, you are actually trying to demonstrate how this calculator can be used in the teaching and learning environment. So you can, for instance, use the function y is equal to x. So when you say y is equal to x, that's again, it's a graph. But when you extend it further to say y is equal to x plus 1, what are the changes that are happening there? And that's when learners are able to interpret and analyze and compare the characteristics of this function. For instance, if you say y is equal to 2x plus 1, you throw it on the same Cartesian plane. You throw the graph of y is equal to x plus 1 and also the graph of y is equal to 2x plus 1 or y is equal to 3x plus 1. And then there, learners are able to see, to visualize. And for the fact that they will be able to visualize, they can interpret, analyze, and compare. And these are critical skills that we need to equip, that we need to develop in our learners: interpreting, analyzing, and comparing. And remember, they cannot interpret, analyze, and compare if they cannot visualize, if they cannot see the functions that we are talking about. So by altering the c in the equation, y is equal to x plus c or y is equal to mx plus c, which is a linear function, the learner can discover how the c affects the y-intercept of the graph. Often teachers complain that the drawing of graphs by means of the table method and plotting is very time consuming. The calculator draws the graphs for you and allows more time for analyzing the results and formulating conclusions about the properties of graphs. So that's how you should respond to this question. And again, you are not limited to using these functions that I'm giving you as your answers. You can use any function that you can think of, and also the effect of various parameters on the basic graphs. So you are not limited to linear functions. You are only focusing on all the graphs you can think of, but use just one graph or two or three to explain or demonstrate your understanding of graphic calculators can be used. On 3.2, a calculator can be used to identify number patterns. This is a separate question of which it confused a lot of you because it was also having 5 marks allocated to it. But that issue of 5 marks will just award it in issue errata. So that question, it should not be confused with the previous question. So the follow-up question to 3.2 is the one on 3.2.1, which is the one which is having 6 marks there. And then when you look at this table, we're trying to look at number patterns. What pattern do we observe? Can we use the calculator to make the observation, to observe the pattern, to make conjectures? That's what the question is all about. So there you are given the x values, and then you are also given sine squared x plus cos squared x. So in that instance, you are given a trigonometric identity of sine squared x plus cos squared x, and you are also given the values of x there. So when you substitute the value of x by 10 in the identity there, the answer that you get there is 1 if you round it off to a nearest whole number. All the values of x, when we substitute them in that identity, we get 1. So when we move to the next question, you are required to describe any patterns you observe. So this is not just for you as a student teacher, but it's something that you should embody in your classroom practices. You allow learners to make certain observation or to describe what they see from the table. What is it that you are seeing? So you can see that for every value of x, sine squared x plus cos squared x is equal to 1. So in other words, this identity is true for every value of x. You can think of any value, not limited to the ones that you are given there. You can think of large numbers or bigger values. This identity will be true for every value of x. That is why the question 3.2.3, do you think the pattern is true for every value of x? Yes, from the table, the identity is true for every value of x in that case. Moving on to question 4. You discuss 4 principal types of CAI programs as outlined by Pease and Lober. This is specific. There are more than different types of programs, but in these instances, we are just focusing by the ones outlined by Pease and Lober 1977. So those 4 principal types are drill and practice programs, tutorial programs, simulation and gaming programs, problem solving, or free interaction programs. Now, the most important thing, you are not just going to label, or you're not just going to give these practical types or principal types of CIA programs. Now, you must also justify or discuss each program that you are giving. For example, if you focus on drill and practice programs, what does it do in the teaching and learning of mathematics if we were to use it? These are quite common and are usually of the branching variety, which means that if learners have problems at a certain level, the program automatically moves to a simpler level. Once the learner has become more proficient, the program moves back to the more complex level, Programs in mathematics, science, and language are often of these types. And these drill and practice programs, you can also think of the way you teach maths. You don't just give learners complex problems. You start with the simplest, going to the complex. So even the drill and practice program, it does the same thing. It starts learners with the simple programs or simple learning activities, and then you move to abstract. The more learners become proficient, the more the level of questioning changes in terms of their level of proficiency. So the other programs that we have is tutorial programs. These tutorial programs differ from the drill and practice programs in that new information is supplied by the program. Based on the learner's responses, further information is then supplied, which often becomes more and more abstract. The third program that we have is simulation and gaming programs. The computer creates realistic situations to which a learner can react. And then the last one, we have problem solving or free interaction programs. Here, the learner makes use of the computing properties of the computer and of the computer's ability to create new and unfamiliar situations. In mathematics, for example, learners can experiment with instant solutions to complex mathematical problems without hours of work necessary in the case of conventional calculations. And then we have question 4, continuing, where you are supposed to draw a checklist that you can use to select the digital media and evaluate mathematics resources found on the internet. Now, you might be aware that there are a lot of mathematical resources on the internet. But not all these resources are mathematics. So you need to have your own criteria, or you need to have a checklist that you can use to select these resources that you find on internet. For example, some of the things, but not limited to the criteria that you can look at, you can think of accessible to all students. If you were to use a certain resource in your classroom, will it be accessible to all students? If it is not accessible to all students, it means you are going to disadvantage other students. And once students feel they are being disadvantaged, they are likely to withdraw from their learning experiences or from their learning processes. So this resource, again, that you select, it must be easy to operate. Will learners be able to handle the resource? Will they be able to operate it? The other most important criteria that you can look at is the issue of the relevance to the content. You cannot use a resource which is not relevant to the content that you are teaching. For example, the resource that you choose, you must choose the resource that you are going to use to teach a specific concept. Not all the resources can teach all the mathematical concepts. For example, if we focus on GeoGebra just for the presentation sake, this resource, of which is the software, it can be relevant in terms of teaching the graphs, probability, statistics, and so forth. So you took, you identify a resource based on its relevancy to the content that you are teaching. And remember, these criteria, you are not limited to the ones that I've identified. You can use other criteria which you may find that they are relevant to this question. And then moving to question 5, we are, in this case, supposed to discuss the main aim of applying technology and media in the teaching and learning of mathematics. Again, this question is very broad, and you can use your own language, you can use your own understanding to identify or to discuss the main aims of applying technology and media in the teaching and learning of mathematics. If someone were to ask you as a student teacher in mathematics education, what are the main aims of applying technology and media in the teaching and learning of mathematics, how would you respond to this question? So sometimes you are not going to be restricted or limited by what tutorial letter 501 is saying. You can use your own way, elaborate in your own way, in answering this question, because it's a very practical question which is open-ended. But most importantly, the application of technology and media in the teaching and learning of mathematics should enable students to attain learning experience through making informed decisions when accessing, capturing, and analyzing data, as well as manipulating and interpreting and processing information. So looking at this point, you can think of the role of the applying technology in the teaching and learning of mathematics is for accessing, capturing, and analyzing the information. Not only that, but also manipulation and interpretation and processing of information there. The other point that you can think of is its problem-solving skills, using critical and creative thinking within the context of business, information, and communication and technology. Remember, we are preparing learners that will be able to respond to the needs of the society, not just limiting them to mathematics learning environments. The knowledge they acquire, the way they do problem solving in mathematics, they should be able to discuss information, to communicate effectively using technology in that instances. So technology again comes into play in developing their critical and creative thinking skills. The other point that we can think of is acquiring basic knowledge and skills to improve their competency in interacting with different computer applications, such as word processing, spreadsheets, database, and presentations. So all these skills, technology makes them possible for us in a learning environment. Learners become able to interact with different applications. They can use word processing, they can use spreadsheets, they can use databases and presentations and so forth in the teaching and learning of mathematics there. And most importantly, applying knowledge and skills, as well as understanding environmental and global issues that are linked to the subjects. Mathematics does not exist in isolation. Mathematics does not exist in isolation. There are a lot of interactions between various subjects. In other words, subjects are linked with each other. They can be integrated, hence we talk about integration in the teaching and learning of mathematics there. And lastly, communicating effectively across a broad spectrum of environments by using appropriate software and communication-related tools. So these are some of the most important aspects of applying technology and media in the teaching and learning environments. In question 5, we still continue, which is the last question there. It involves the globalization or the impact of globalization in mathematics learning. So in this question, you were supposed to discuss the effect of globalization on the learning of mathematics. And there you are restricted to base your arguments on the following premises. The first one, it's mathematics curriculum and globalization. The second one, it's mathematics teaching resources and globalization. Now, when you look at the first premise there of mathematics curriculum and globalization, mathematics curriculum must reflect the global context. The mathematics that we teach to our learners must not only be limited to a local facts there, it must be in a broader or international level, because our learners, sometimes they go overseas to further their knowledge in this area of mathematics. So the content or the curriculum must actually reflect the global context so that our learners will be able to be competitive at a global context. Secondly, the selection of mathematics knowledge for the curriculum must not only be confined to local facts and must contribute to learners' high knowledge, high skills, and social transformation. So that's when we look at mathematics curriculum and globalization. And again, you can interpret this in your own way without directly copying this from the tutorial letter. What is your understanding of mathematics curriculum and globalization in your own ways? If you were to elaborate this to someone who does not know or and understand these concepts there, how would you describe this to someone in such a way that they understand what you are saying? So this question is about that. What is your understanding of mathematics curriculum and globalization? So you look at the global context there. You move away from local and go into global context. The other part or premise that we are going to focus on is mathematics teaching resources and globalization. Now, again, in this question, what is your understanding of this question? You look at teaching resources and globalization. Is there any relationship between these two? And if there is a relationship that exists amongst these two, what is that relationship saying to you as a mathematics teacher? Globalization affects teaching resources in a sense that the textbook must be augmented by other resources like computers, handheld devices like tablets, cell phones, and many other technology resources. So in other words, textbook alone is not enough in the teaching and learning of mathematics. You need to use or supplement it with other resources, such as computers there. For instance, if you want to teach graphs, you can use GeoGebra. If you want to teach counting, adding, you can think of base 10 blocks there. So these are other resources that you can use in your teaching environment so that learners develop their understanding or their conceptual understanding. And it's not only going to enable learners to develop their conceptual understanding, but also enhance their ability to learn mathematics and create a fun learning environment. Mathematics classroom should be fun. Learners must enjoy mathematics. And for them to enjoy this mathematics, it's up to you as a teacher to make sure that you use resources. And some of these resources learners are familiar with. For instance, learners are able to use cell phones in the 21st century. So we need to capitalize on these resources, use them because learners are familiar with these resources. So we need to use them as a learning resources in our classrooms. Secondly, augmenting a textbook with other resources can enable learners communicate effectively using visual, symbolic, and or language skills in various modes. Remember, mathematics learning or in a mathematics classroom, learners must be able to visualize these concepts that we are seeing. So using augmentation or augmenting the textbook with other resources, it gives learners opportunity to visualize these resources and also touch them. As for example, in earlier question, we're talking about manipulatives, visual manipulatives there, such as base 10 blocks. So when you use this in your classroom to augment the textbook, learners are able to communicate effectively. If you ask them to identify things such as edges, if you ask them to identify various mathematical concepts, it will enable them to develop their language appropriate for the teaching and learning of mathematics. So those are some of the things you need to look at. Again, and I emphasize this for many times now, do not directly copy this from the guide. It's just there. Tutorial letter 501 is just there to guide you. What matters most is your interpretation of this information that we are giving you as a student teacher. And most importantly, when you go for or when you prepare for your exam, or your upcoming exam, please think of the general concerns that I have highlighted earlier on. Let's quickly recap on those. For discussion questions, always write in point form. Don't write in essay form. Just be concise. Very long or very short answers. Your answer length to each question should be divided by the number of marks. If a question worth 2 marks, you cannot write 10 points. You cannot state 10 facts for such a question that worth 1 or 2 marks. So always respond to the question that is being asked and do not try to answer or do not try to deviate from what has been asked. Always try to answer the given question. And please, for further exam-related queries, just use the contact details. Mail is there, and line is there for queries on your examination. I'll be ready and to assist you in terms of